right, so good morning or good afternoon, everyone, depending on where you're joining us from. My name is Jesse, and I am with Exploring by the Seat of Your Pants. If you're joining us for the first time, we're all about bringing conservation, adventure, and science into classrooms around the world. And I'm particularly excited because today, and this session, marks the first time we've ever done a sort of joint double program on one of the coolest expeditions in the world. So, as a little bit of background, over the last few months, we've been partnering with Reach the World. They're an amazing organization that shares our commitment to reaching out and sharing exploration and science with kids around the globe. And we've been partnering with them to highlight the MOSAIC Expedition. So we'll be talking about this more, but I will bring it up on the bottom of the screen. The MOSAIC Expedition is the largest Arctic expedition in history. It is comprised of scientists from all across the globe, floating in sort of an elite research lab slash ship slash all sorts of cool stuff up near the North Pole. So doing some incredible work over the last few months, and many scientists have been featured on this program, highlighting everything from guarding against polar bears to atmospheric science, biology, and more. So earlier today, we were lucky to be joined by Antonia Immers. She joined us from Bremerhaven in Germany, talking about data collection on the MOSAIC expedition. Now we're in Boulder, Colorado, where so many of our speakers seem to come from. I think Boulder is just like the most jam-packed place in the world for science, I think, by Jackson Osborne. So he was an engineer on board the expedition on leg 4, and he's going to share with us today a little bit about what it takes to do engineering at the top of the world. If any of you have seen The Martian, you see that extreme environments promote some really creative solutions to some great engineering challenges. So we're going to learn a little bit about those today with Jackson, and I'm going to turn it over to him to take us away. So Jackson, thank you so much for joining us. Come on, demute your mic, and we're good to go. Let's take us away.
Hello, everyone.
Hi, guys.
All right.
And I got your presentation up whenever you're ready.
All right.
Let's do it.
So this presentation is about rebuilding the MOSAIC Central Observatory Ice Camp. A little bit about myself. Who am I? My name is Jackson Osborne. I'm an enrolled member of the Choctaw Nation of Oklahoma. Colorado native, so I was born and raised here in Colorado. I attended the University of Colorado, Denver, where I earned my Bachelor of Science in Electrical Engineering in May of 2017. Currently, I'm an associate scientist for Ceres and soon to be an engineer for NOAA. So what in the world is MOSAIC? So MOSAIC stands for the Multidisciplinary Drifting Observatory for the Study of Arctic Climate. MOSAIC is a year-long international Arctic drift expedition focused on the Central Arctic sea ice. It's composed of different teams. There's a team atmosphere. They are concerned with the measurement of atmosphere above the ice, everything from the ice surface all the way up to around 35 kilometers, which is just past the stratosphere there. There's Team Ice. They were focused on the ice itself. So they took ice cores, they did thickness measurements, snow depth measurements, tracking the ice dynamics. There was Team Ocean. So they did measurements of the ocean below the ice. They did CTD samples at different depths, anything from meters to thousands of meters into the ocean, depending where we were. There's Team BGC. They were interested in the chemical processes between the ocean, microorganisms, and the ice. There's Team Eco. They studied the aquatic life, such as plants and animals, like plankton, copepods, fish, and other sea creatures, as I refer to them as. There's Team Data. So yeah, all these measurements, all these people collecting data, what do you do with it? So there was a team solely dedicated to taking the data and saving it, backing it up, making sure we get it back on land for future use. There was logistics. They were involved in a lot of the bear guarding, infrastructure such as power lines, some of the pathways that you use to get around the ice. They did a lot of the cargo operations that involved the crane, and other stuff, other logistics. So this expedition has been 12 years in the making, and to me that's just amazing. So it takes place aboard the Polar Stern, seen here on the right, and the idea was to freeze this ship into the transpolar drift. So I found this figure online. It kind of illustrates the transpolar drift. And before MOSAIC, I had never even heard of the transpolar drift. Being an engineer, I'm kind of stuck in the lab sometimes. Before, I used to think that the ice cap was static. Boy, was I wrong. The Arctic sea ice is anything but static. It's constantly changing and moving. So up here, there's this phenomena. So above Alaska here is this called the Beaufort Gyre. It rotates here. And for MOSAIC, we were interested in the transpolar drift. We were going to freeze the ship in October above Siberia here, and then it would drift all the way down to the Fram Strait, where eventually the ice would melt back into the sea. So here it is, 4th of October, 2019. The ship was frozen into the ice, and each of these colors represents a different leg before ours. I was on leg 4. So the red is leg 1, yellow is leg 2, and the green, this long leg here, was leg 3. It was frozen into the ice there, and then drifted all the way down right above Svalbard here. So for leg 3, the green one, the ice drifted a lot faster than they predicted. Adding to the challenge was COVID-19, which complicated many things, as we all know. The exchange was delayed, and the icebreaker for resupply was not available anymore. So how do we overcome this? This is where my journey begins. At the end of April, we were to be in Bremerhaven, Germany, to undergo a quarantine for about 2 weeks to ensure that nobody was ill. It'd be bad news if that were to happen. Much planning went into getting us where we needed to be. Thanks to all who were involved. It was a massive effort. So this is a photo of Jonathan Hamilton. He was on the drone team. He was the pilot for the drones. And myself in Bremerhaven on April 30th. We took 3 planes and 1 bus to get here. It took about 20 plus hours, and by the time we took this picture, I was extremely exhausted. So the quarantine started on May 1st. There were a series of swab tests to pass before they would let anyone travel. Thankfully, everyone passed. Not a single person had COVID. After passing the test, we boarded the ships that would take us to meet with Polarstern in the fjords of Svalbard. There's that heart-shaped island up there. This is the German research vessel Maria S. Marion. All the teams except for Team Atmosphere were on this ship. So Team Atmosphere, along with the rotating crew of Polarstern, were on this ship. It is the German research vessel Sonne, which stands for sun in German. So they split us up because there was not enough space on either of the vessels to accommodate the entire exchange. We would wait outside of Svalbard until Polarstern could make it out of the ice to meet us here. Polarstern leaving the ice would mean that most of the research camp would have to be packed back onto the ship, except for some of the instruments. We left some instruments that were measuring the atmosphere. There were a couple buoys there and other measurements. I will note that this was my first time on a ship in the ocean, and what an experience. So on the morning of June 3rd, 2020, Polarstern arrived in Svalbard for the exchange. There would be several days for handover from Leg 4 people to Leg 4 people. This time was for briefing of new participants, cargo operations, and getting everyone where they needed to go. A few days later, we found ourselves at the ice edge, and I had never seen anything like this before. It was amazing. So after entering the ice, we started to see wildlife, whales, lots of birds, and bears. Note the melt pond there. The ice was changing with the seasons, and the melt season was underway. So these curious bears were very popular. We saw this mother and her cub, and they were awesome. We saw quite a few bears. One thing that I thought was cool was that every bear had their own personality. Some were curious, like above, kind of checked us out a little bit, so the equipment. Some did not want anything to do with this at all. They kind of just did their own thing on their own journey. Some were just enjoying themselves, pretend like we weren't even there. The little one was so cool to see. It was truly amazing to see these sacred beings in their natural environment. So how do you rebuild a research camp? Rebuilding the MOSAIC CO was designed to happen in 3 phases. There was a phase approach. This approach was designed so everything would come together smoothly. So phase 1, team leaders met to plan the sites where everything would go, and there were exploration teams that went out to check out the state of the ice flow. There's phase 2, where major infrastructure was to be installed, such as power lines, research huts, and flags for marking the pathways and research sites. There was phase 3, the final phase for the teams to focus on their individual sites, get everything set up the way they wanted to. It took us about 8 days to get from the ice edge to the ice flow. I think we were stuck in one spot for a couple of days because of ice pressure. So we entered phase 1 on June 20th. Teams went out to explore the flow and to assess the state of the ice. What they found is that the ice was melting and melt ponds were forming everywhere. Initially, there was a layer of snow that covered many of the melt ponds that were forming. So you could just be walking something like this and splash, step in a pond and not even know it was there. And some you could see. Now that we were in melt season, work on the ice would be really wet and really slushy. Phase 2 started on June 22nd. Major infrastructure was the focus of phase 2. Many of the instruments on the ice required power to operate. Power lines had to be established and efficiently routed to the sites that required the power. It was a scramble to get everything back out onto the ice, but at the same time, everything was carefully coordinated. There were meetings every night after dinner and every morning before going out onto the ice. So it was an all-hands effort to get all of the equipment back out onto the ice. Much of the equipment had to be lifted off the ship using the crane or even a helicopter. Some of the teams created ways to make their equipment lighter and more mobile. If ice flow were to become unstable, everything would have to come back aboard, pull or stern. More on that later. So phase 3 started on June 25th. For Team Atmosphere, we were working to get Met City built again. This would mean that the Met Tower, seen here laying down, had to be reassembled and raised. The Met Tower had various meteorological sensors. We measured things like temperature, atmospheric pressure, 3D winds, snow depth. There were snow particle counters. There were a plethora of instruments on this thing. So it's quite heavy. So we needed a lot of help to raise it. A few days later, we would raise the tower. This took many people to accomplish. The tower is loaded with the instruments and ready for raising. The process of raising the tower required many people. Some lifted, you see those in the back there. Others stabilized the tower, pulling on these guidelines. And then there was a come-along, which you can see Dr. Shoup there. It's kind of like a winch, and that is an anchor to the Met head and used to pull on the tower. Here, several of us are pushing to get the tower up. And we're almost there, and it was up. Time to lock it in place with the bolt and secure the guidelines for stabilization. The Met Tower was just one of many instruments that had to be set up. I mostly show the systems that I helped with, some of them. Another system we had for atmospheric measurements was the ASFS, or Atmospheric Surface Flux Station. This, along with the Met Tower, were designed here in Boulder, Colorado. The skis worked awesome for maneuvering this thing around. It was like a bobsled when we moved it around. It was kind of fun. We relocated this system to measure the first year ice, which is the ice that was formed in the recent year. So there was a team that would jump in the helicopter and they would take scans of the ice. This is extremely useful for mapping out the ice flow. So here you can see the border of the ice. And later, after everything was set up, we had a map. And you can see like these red areas, it's kind of like no-go zones. You didn't want to step at somebody's sampling area. I mean, so this is what the research camp eventually looked like after we had spent at least a week setting things up. I mean, every team was out there working. There were certain paths you would have to take, so those green lines there, you didn't want to step in anybody's sampling area. That was important. You want to take sample areas that represented the Arctic well. So this version of the flow would be appropriately named MOSAIC Flow 2.0. So going with Flow 2.0. Now that we were set up, what did we do? So after surviving polar winters, some of the equipment needed some repairs. In this photo, I'm fixing a USB cable for one of the camera systems on the ASFS sled. Everything that was set up, we just needed to maintain the equipment and make sure the data was being saved. Which sounds easy. Some of the maintenance required ablation shielding. So these cover the base of the tower to keep it from melting out from underneath. We constantly had to take the shovel and shovel snow onto the base because it was melting. The sun was out all day, so it's always melting. So it wasn't all work and no play. Here's the Leg 4 group photo. Mostly everyone on the ship. This was during the halfway celebration for our accomplishments so far. Such an awesome group of people. So this gives you an idea of how many people were on the ship. So one unique thing I got to experience was Polar Day. The sun never set. It just went around in circles. It was totally different. It could be midnight and the sun would still be shining. This is my first time experiencing Polar Day, and it was weird at first, but it's something you got used to after some time. So here's a map using satellite imagery used to estimate the ice coverage. The darker the colors, the more ice coverage. The lighter the colors, the less ice coverage. Here you can see we were nearing the ice edge, which the blue on the bottom there is the open ocean. We often looked at maps like this to see how close the ice edge was. Near the ice edge, the ocean currents and swells are so strong they can break these flows into pieces. The closer we got, the more we planned on how to pack everything back onto the ship. That day came on July 28th. We received information the flow would certainly break up as we were really close to the ice edge. It was all hands effort to get everything back onto the ship. This is a photo of us breaking down Med City. It took many trips with that ski-doo, loading it up and hauling it back to the ship and using a crane, putting it back on the ship, organizing. It was quite the effort. So here we are, lowering the tower. It's a lot easier to take apart than it was to build up. I'll say that much. What took us about a week to build, we took down in just over a day. Pretty impressive, if you ask me. So the following day, the flow would break into pieces by the power of the ocean. This is what remained of Met City when the flow broke up. So you can see this little pond here. That pond is this pond on the bottom here and also here. You can see that this was the whole flow. It was still intact when we were taking everything down. And here it is. So you can see there's cracks everywhere. There's open ocean, leads, and it is extremely melted. So I think right here there was an X on the ground, and that's where the Met Hut was. So we had a proper send-off, scientist style. This is a weather balloon, and we often would write things on them and send them up into the stratosphere. So we got to see the flow at the end of its life cycle. We used the remaining time to pick up some of the equipment that was in a distributed network around the CO, which was buoys and other equipment, things like that. Shortly after that, the Russian icebreaker, seen here, the academic Tryashnikov, met us in the ice for Leg 4, Leg 5 exchange. Timing was impeccable, in my opinion. So some of the numbers. So some of the leg 4 numbers. I got this off the app there. We drifted for 44 days for 210 nautical miles at an average speed of 1.4 knots. The maximum drift for a 24-hour period was 17 nautical miles. I mean, at one time the flow was actually spinning, and you can see that. At least I was bear guarding, and I was looking at the balloon tether, and you could see it change. It was kind of weird for me. So some of the expedition numbers. Expedition lasted for 389 days. This is including leg 5, the leg after ours. There were 7 icebreakers and ships involved. Participants from 20 nations. Polar Stern spent 10 months frozen in the ice, 300 days with the flow there. We're 1,500 kilometers from the nearest human settlement. We're 60 bear sightings. The coldest temperature that it reached, which was during polar winter, was minus 42 degrees Celsius. And here is the drift path with leg 4 on it. This blue path here was where we were. A little zoom in here. Somebody developed this. So here's Svalbard. We got picked up here. We traveled all the way to the ice edge. And here we had to go through the ice to find the flow, which there were a number of instruments that were reporting GPS via Iridium satellites, so we could find the flow and get back to taking data. And it traveled, we drifted with the flow all the way until 31st of July here. And you can see as we started cruising around, picking stuff up, and eventually met the Russian icebreaker. So we traveled we got up here and it was about 82 degrees north. And by the time of the end of the life cycle of the flow, we made it to 79 degrees north. And we also crossed the prime meridian, which is where the eastern hemisphere meets the western hemisphere. That was cool. So we hit a record minimum with the sea ice extent. The current record was set in 2012. We saw the second lowest Arctic sea ice this year. Even some of the more experienced scientists said that the ice was really thin this year. So here's me reflecting on an incredible journey. Experience was wild. Thank you for your time.
Thank
you. People made it possible.
Yeah. Thank you for your time, Jackson. What a cool story. I love when we talk about temperatures, because it's something that we always get from kids as a question. When Fahrenheit and Celsius meet at the -40 mark, you know that you're in a very, very cold spot. So that's awesome. If you want to come out of screen share, we've left that slide up for a little bit, and then you can come and have a bit of a conversation with us. This is great. If you're on YouTube, people, please do share your questions. We'd love to hear where you're joining from and take your questions there. We have had a few come in through email as well, which is great. So I'm going to start, Jackson, with it's your first time on a ship. And I mean, I know you're waxing mystical about this, so I think we can assume the answer. But would you go back on an expedition like this? Would you go back on MOSAIC if you were invited back for another leg or another research expedition at sea?
Yeah, I would totally go back. It was, I've never experienced anything like that. Yeah. Anybody were to ask me, I would definitely say yes.
Awesome. All right. And then, why is this so important? I mean, this is something that we've covered with the MOSAIC Expedition a lot over the last few months, but why is the data that you guys were collecting up there so important? Like, why care? If I'm a student and I hear about this expedition, what's the interest? Why am I concerned about this or fascinated by it?
Yeah, so the expedition part of this is of MOSAIC is over, but the data is extremely important in that they use that data to help with models, which eventually models are used to predict the weather. And the Arctic up there, the data that was collected, that environment affects us down here. So when you get a Arctic blast, or I'm probably not saying it right, but in the lower 48, it gets really cold. That air comes from the Arctic. And to predict things like that, that data is used in models to make the models better.
Well, one thing that, I mean, when I was a little kid, we never had to hear about any of this stuff. And certainly as I've gotten older and now the generation of kids, they're hearing about climate projections, they're hearing about climate change and what it's going to affect and what it's going to be like in 2050, 2100 and beyond. And I mean, that is all built up with data like this. And what makes MOSAIC so special is that it was the largest team of scientists, the most data ever collected in a really remote region where people don't get a chance to collect this much information. And so it's going to help make those prognostications that much better and help us make policy decisions to help make a better world for everyone, which is really an exciting and invigorating thing. So I'm glad you got a chance to mention that. Peter in Chicago wants to ask, did anything surprise you about the Arctic? I think everything seemed to surprise you about the Arctic, but does anything really jump out, Jackson?
There were a lot of things. Polar day, that was pretty strange at first. I think the ice itself. Yeah. So you saw that in the photo there was we first got there was snow and you could step somewhere and just step straight into a pond. Every day the ice changed. It was different from the day before, so you could walk somewhere and you leave footprints, and the next day you go out there and it's melted even more and you don't even see your footprints anymore. And the ice, I think that's what probably surprised me the most, is the ice and how fast it changed and how much movement there was of the ice.
Yeah, well, you mentioned that, and I love that. You're one of the first people to mention the fact that, like, when I was a kid, if I thought of the Arctic at all, and it was not something that was very much in my mind, it was certainly like a stable ecosystem, not something that's ever changing, ever, and whenever we talk to people that have been to either the Arctic or Antarctic, they marvel at the ice. They marvel at the look of it, the feel of it, the changing of it. It's something that I've never experienced personally, but I would be inclined to go just to hear and see this in person, because it's such a magical experience, such a transformative thing to everyone who seems to encounter it. So it's very, very cool. Yeah. Jackson, what's next for you? I mean, you're back from this expedition. Is there any big project you're thinking of next? Is there a place you'd like to go? Did this change sort of what you're thinking of doing now?
Well, for now, it's so I do a lot of work in instrument development. I do software and hardware development for some of the smaller instruments using a lot of microcontrollers and stuff. So I think right now I'm working to develop some instruments, some for like a micro buoy, and then there's some that need to go on a UAS, a little remote controlled plane there. Yeah. So I'll probably dig into some of that work.
Awesome. I love this question, and it's a question that we get from a lot of students. So not every engineer is going to get the chance to do an incredible sort of expedition like this, but to an aspiring engineer, is there anything that you'd recommend, given your own experience going through school in it, sort of what kids can look forward to or what they should expect going in?
Yeah, for engineering, find what you love to do. Follow your dreams, and don't give up. Engineering is hard, but totally worth it. That's what I would say.
Hey man, that's great. And it's so exciting. We get to cover this with space and just general exploration as well. But for kids coming up, like, this is the coolest time to ever be in these fields. There's more amazing work being done in engineering right now, possibly than there ever has been, whether that's aerospace engineering, and look at what SpaceX is doing. We've got electric vehicles, we've got green energy, popping up all over the place, which is really exciting. Biomimicry, like, it's just, there's some wild stuff going on right now. So if you're keen on this, tinker, play, learn, get internships, go visit labs. Most scientists don't bite, so you get a chance to learn directly from people that are doing the work and hear from them firsthand. Some really exciting opportunities out there. So I'd encourage all our students, whatever age you are, to get out there and do that. Jackson, is there our classic question, our number one most popular question, is there a favorite part you had on the expedition? No pressure.
Yeah, that was a hard one.
How about since you loved it all? Is there anything you just hated? Like, was there like a worst moment? You're like, I would never do that again.
Lots of wet socks.
Yeah. It's funny. When we talked with Tony earlier, she mentioned that people always had to bring a second pair of socks when they went with them, because if you got your feet wet, that actually can be a fairly dangerous situation. So you're always prepped. I mean, she had all these pictures of her walking in the water, which I mean will tend to increase the chances of you getting wet socks. So if you stick around on the ship, you're pretty good. Another question we've gotten a lot lately: what kind of food was there on the ship? How did you eat when you're out there?
Yeah, so there was not many fresh vegetables towards the middle and the end there. So it was a lot of meat. There was a lot of German food, so a lot of pickled cabbage, stuff like that. And yeah, it wasn't too bad. There was always hot chocolate or coffee to drink.
That's all you need, really. I like that the fresh vegetable store just like completely was decimated in the first few days, and just like pickled cabbage from then on. Sauerkraut galore. Nice to see the culinary influence of this international journey. That's amazing. Peter wanted to ask again, did anything break that you couldn't fix up in the Arctic?
There was a couple things. For instance, we had a sled, one of those sleds that I showed, that one of those got completely eaten by a ridge. So it pretty much got stuck in the ridge and then disappeared. So that was definitely unfixable. Let's see, for my leg, there was one of those sleds that was in a distributed network, and one of the sensors wasn't working, and I couldn't fix it until I got out there, which required getting a helicopter flight. It would take us about, I think it was like 7 or 14 nautical miles away from the ship to get out there and fix it. So
cool. That's the most, metal way of getting to an engineering fixing site of all time. Like if only like in your typical day-by-day lab, it's like, oh, call up the chopper, let's go. By the way, I appreciate your willingness to admit sort of not being able to fix something on YouTube. So thank you for that, because you could have just said, yes, every problem that came my way was just lickety-split. So fantastic question, Peter. Thank you. Jackson, you know what? We are running out of time. Like time flies and you're having fun with these things. So is there a last message you'd like to share with kids about MOSAIC, about your own journey, just keep them excited about this and keep the learning going?
Yeah, I would say do what you love. And, as a Native American, I was taught about the 7 generations. And I think the Arctic is pretty representative of that, in that the 7 generations before me, they saw a different Arctic than I saw, and the 7 generations that come after me will see a different Arctic that I saw. So it's just, they say the 7 generations before you represent them, and then the 7 generations after you, what you do in your lifetime affects them, and that's definitely applicable.
Jackson, I really appreciate you taking the moment to mention that, and to mention that heritage and tradition. I think it's something that in October, we did Secret Path Week, which is one of the biggest weeks we've ever done in partnership with the Gord Downey Cheney Wenjack Fund here in Canada. So we did 15 programs featuring Indigenous activists, stories, tales, and it was really like just a magical experience to get to highlight this. And those sort of that traditional knowledge, two-eyed seeing is something that we've covered a lot from British Columbia First Nations and some of the amazing speakers we've had from there. And I think that it's just so valuable to get to highlight that to kids, whether or not they've ever experienced stories like that in their schooling or in the past, because it just promotes a different way of looking at the world. So thank you for sharing that very much. Yeah. Jackson, this has been great. Thank you so much for joining us today. I want to stress for all our kids at home too, if you want to learn more about the MOSAIC Expedition, check out the link I just brought up on the page. Incredible stuff. We also have a bevy of past YouTube videos with scientists that have joined on many legs of the expedition on our YouTube channel. Reach the World is the organization we're partnering with for this, so thank you so much to their team for making this all possible. And if you want to check out Jackson's actual post on this, if you want to follow up this talk and read a little bit about what he wrote about, check out this very unwieldy and large link at the bottom of the screen now, and hopefully you can copy that down. Jackson, thank you so much again, and have a wonderful rest of your day. Thanks, man.
Yeah, thank you.
Awesome. All right.